Welcome everyone. Before looking at long division in algebra, let us revise long division with numbers we may have forgotten because the calculators does much of the work for us. For example, 528 divided by 2 can be achieved as follows. 528 is known as the dividend, and then 2 is the divisor. Now this is how we proceed. We put 2 outside and then 528 put inside. 2 divided into 5. 2 divided into 5 here goes 2. Now you put 2 above 5. Multiply 2 by 2 gives 4. Subtract that 4 from 5 gives 1. Drop the 2 and write it here. Again, the same procedure. 2 divided into 12 gives 6. Put that 6 above 2 here. And gain 2 multiplied by 6 gives 12. Subtract the 12 from 12, you get a 0. Again, drop 8. And then we proceed. We repeat the process. 2 divided into 8 gives a 4. And put that 4 above 8 there. And then 2 multiplied by 4 gives 8. Subtract that 8 from 8 here, you get a 0. So that means 528 divided by 2 is equals to 264 exactly. Maybe if we can look at one more example, like 208 divided by 16. Again, 16 is our divisor and 208 is our dividend. And then we proceed the way we did previously here. Now 16 divided into 2, well, that is there's no number of times that 16 can go into a 2 because 2 is less than 16. All right, so what we do, we combine 2 and 0 and then ask again ourselves, 16 divided into 20 gives what? That is 1. All right, so we put that 1 above 0 here, put 1 above 0, and then 16 multiplied by 1 gives 16. Subtract that 16 from 20, you get 4. Drop 8, and then again 16 divided into 48 gives 3. And that 3, you write it above 8 there. So that 16 multiplied by 13, 16 multiplied by 3, I mean. 16 multiplied by 3 gives 48. And then again, subtracting that 1 from 48, you get a 0. So that 208 divided by 16 is 13 again exactly. All right, let's look at one more example where we shall be having a remainder. Like for example, if you have 172 divided by a number like 15, and we proceed again as follows. 172 is a 172 is the dividend, and the divisor being 15. And again, 15 divided into 1 is impossible, so we combined 1 and 7, so that 15 into 17 is 1. We put 1 above 7, and then 15 times 1 is 15. Subtract 15 from 17, you get 2. Drop that 2, and 15 divides into 22 how many times again? 1. And then again 15 times that 1 gives 15. Subtract 15 from 22, you get 7. So this means 172 divided by 15 is equals to 11 here, and the remainder is 7. So we have the remainder as 7 over 15, and this is how we put it. And this one is the same as 11 and 7 over 15. So it means 172 divided by 15, you will get a remainder of 7. Or in other words, 15 goes into 172 11 times with a remainder of 7. Now, on to our polynomial division. The same principle applies, and here below here I'm going to give an example, 1 or 2, of division in algebra, which in some respects is similar to long division with the numbers. The main thing here is polynomial division. And one question one might ask is, what is a polynomial? Okay, a polynomial is simply an expression. If you come across an expression, fx equals a plus bx plus cx squared plus dx raised to 3, and so on. This is an example of a polynomial, and as we proceed, I'm going to show you using a few examples how to divide polynomials. And why polynomials? Polynomial division is sometimes required when resolving into partial fractions. The other area is when you want to evaluate factors of a quadratic equation or something of the sort. Remember, quadratic equation is also a polynomial of the second degree, and those aspects I shall discuss in a whole different chapter. Now, right into our example, divide x minus 3 plus 2x squared by x minus 1. This is an example of polynomial division. We are going to employ the principle of long division with real or whole numbers, or with the numbers. Okay, in this case here, x minus 3 plus 2x squared, just like we did in the other example, this one is going to be our dividend, and x minus 1 here is our divisor. The layout we are going to use is the layout we used previously in the 3 examples I gave up here. So we're going to use the same layout to work out this polynomial division. All right. Let's go directly to arranging these polynomials. So the divisor comes outside, and the dividend here we are going to in other words, the usual layout is shown with the dividend both the dividend and the divisor arranged in descending powers of the symbols. What does it mean? When you look at our dividend here, we first of all have to arrange it in descending powers of the symbols. In other words, we just start with 2x squared and then plus x minus 3. Alright, so this is what we put inside here, 2x squared plus x subtract 3. We proceed as follows. We divide the first term of the dividend by the first term of the divisor. So the first term of the dividend is 2x squared here, and the first term of the divisor is x. So we take that 2x squared, we divide by x, and this one gives 2x. So one gives 2x. Put the 2x on top or above the first term of the dividend. So we put 2x there. Alright. Multiply the divisor by this 2x. So we shall take the divisor, which is x minus 1, and then multiply by that 2x. If you multiply, you shall get 2x squared minus 2x. Alright. Subtract to get the remainder. So we are going to subtract this equation here from that one, and if you subtract 2x squared subtract 2x squared, you get a 0. And then we have here x subtract negative 2x. So we have x subtract negative 2x. This one is the same as x add 2x, which will give us a 3x. So we shall have a plus 3x. Then we drop negative 3 right there. We repeat the process again by dividing the first term here, which is 3x, by the first term of the divisor. So that means you take 3x divided by x, you get a 3. So the 3 is positive. You write it next to what you have above there. So that is plus 3. Now x minus 1, which is the divisor, again multiply by 3, you get 3x minus 3. Again subtract that one from the equation, you get a 0. So what does it mean? It means that 2x squared plus x subtract 3 divided by x minus 1, this one gives 2x plus 3 exactly. Alright, now this is how you go about polynomial division, and in my next video we shall look at how to work out polynomial division where you have a remainder. If you like this video, please subscribe to my channel. Make sure you hit the notification bell so you won't miss any of my new videos in the next coming videos. Thank you very much. Have a great time ahead, and may God bless you.